Hi everyone, welcome to Programming School. In the DS series, today I am come up with a linear search algorithm. In searching techniques, we already discussed here the names. That's it. In the searching techniques, the first one is going to be the linear search, and the next one is going to be the binary search. Here I am going to explain the linear search in a iterative method and as well as recursive method also. In the same way, binary also I am going to explain using a iterative method and as well as recursive method also I'm going to explain here. First of all, what is linear search and how I am going to work with iterative method. Then in the next video, I'm going to discuss about how I am going to work with the recursive method. Okay, here it is going to be searching and the algorithm is going to be the linear search. Linear search, that is also iterative method. Okay, iterative method. First of all, the input is going to be like this, and for example some 10 or 20 values, it is going to be size of the array, how many elements we have, and like this the values, not 5 or 10, 5, 6, 7, 8, 9, 10. Okay, for example like this, these are 10 values like this, 10 values, and one more value that is going to be we are going to search the element is in the array or not. For example, I am going to give you here some 66. Is 66 is in this array or not? That is called searching here. That's it. Now here, yes, the 66 is in the list, no doubt about that. Then we have to return as 1 here. If the element is not found, and we are going to return it as a 0, or we can return it as a true, or we can return it as a false, like this. We can whatever we want we can return here. I am going to return either 1 or 0. Yes, if 66 is available, is in the list, right? That's why I'm going to return 1. For example, I'm going to write the method, the search element is going to be 6. Is 6 in this list? No, right? That's why then the output is going to be 0 here. That's it, nothing else. For that, these are the values. These are the values, right? These are the values. These are the array values, and these are the index values, right? These are the index values. These are the index values. These are the index values. I'm going to take I here. How the linear search? Linear means one by one, one by one. It is going to be search is the element is in the list or not. If the element is found, we have to stop there, and we are going to tell that the yes, the element is not, yes, the element is found. Now the search element is going to be, for example, 66. What is that? 66. Now I is at initially at 0 here. I is initially at 0. I am going to check here. I am going to check here is ARR of I, that means ARR means the array, I means 0, ARR of 0 means 5, is equal to search element. Is a search element. Always I am going to write, if it is true I am going to write here. Okay, if it is false I am going to write here. Okay, if it is false, if it is true I am going to write here, this block. In the whole series I am going to write, always I am going to write like this only. If it is true I am going to write here, if it is false I am going to write here. Okay, now if it is true, just simply I am going to return minus 1, return 1, that's it, return 1, that means the element is found. Just simply I am going to return 1, that's it. If the element is not found, just simply in the algorithm I am going to check here what is error of I here. I is at 0, that means 5 is equal to what is search element, that is 66. Is both are equal? No, right? If it is not equal, if it is not equal, just simply I'm going to increment I plus plus, that's it. I have to increment I, that's it, nothing else. That means I is moving into the next value, and again I have to do the same thing again. Again I have to do the same thing. I'm going to check again error of I, that means that is going to be 4. Is 4 is equal to 66? No. Then immediately we have to increment I plus plus. You have to increment I. Then again, what is error of I value? Now it is going to be 3. Is 3 is equal to 66? No, not at all. Then again I have to increment this I value. Now it is going to be 22. Now it is going to be 22. Is 22 is equal to 66? No. If it is no, I have to increment I again. Now the value is going to be 66. Is 66 is equal to 66? Yes. Then I have to return yes, the element is found here. The element is found. Sometimes the question is going to be like this. At what element? At what element the at what position the element is? At what position the element? The element is at fourth position, right? Fourth position. Then I have to return I here. Then I have to return I here. Okay, I will explain each one question, every question. Okay, for example, the element is found. I am going to return yes one. Definitely, I am going to return here one. Okay. Now again I am going to work with from the starting here. The 6 is not in the list, right? The 6 is not in the list. I am going to check with the 5. Is 5 is equal to 66? No. Then I have to increment I here. Is 4 is equal to 66? Sorry, 6? No. Then is 3 is equal to 6? No. Then I is incremented again. Is 22 is equal to 6? No. Is 66 is equal to 6? No. Then it is continuously checking all the elements. No. Triple 2 is equal to 6? No. Then is 1 is equal to 6? No. Then I is moving. Then I is moving beyond the list, right? Now I is moving beyond the list. Then we can tell that there is no element in the list. The element is not found in the list. Then I am going to return a 0 at this position. Clear everyone? Now I am going to write the program for this algorithm. What I am writing here, what I am telling here, what I am discussing here, I am going to convert this into a program, and then I am going to write in the recursive model in the next class. Okay. Now what is the input? For example, I'm going to write ARR of 100, comma, I'm going to write n, comma, and for the iteration, I'm going to take I, comma, and the search element is going to be SC. First of all, I have to read what is the size of the array. The size of the array is going to be n. I'm taking like this, and then I have to read all the values for I is equal to 0, I less than n, and I plus plus. Then I have to read all the values. Then I have to read the array values. Ampersand error of I. If you observe here array is going to be a static memory allocation. If you want to create a dynamic memory allocation, how I am going to create dynamic memory allocation? I already done one video in the previous lectures. Just I am going to share that link also in the description box. Then you will understand how we are going to create a dynamic memory allocation. Okay. After reading all the array values, I have to read the search element here. I have to read the search element. Sorry, I have to read the search element. Yes, up to now the elements, the reading part is done. That's it, nothing else. N is array size, and the next I'm going to read array values. Then I'm going to read the search element, what element we are searching on the list. That's it. Now I'm going to write if condition here. If linear underscore search of err comma n here. Just observe here, I am going to print here true. I'm going to print here true. Else I'm going to print here no. Oh, sorry, false. That is going to be false. Yes or no, or true or false, 1 or 0, anything we are going to print here. Just observe here linear search. I'm going to use a function call. This is the function call what I'm writing. This is the function call, and the function call is working as a condition in the if block here, right? Yes. Now the function call is working as a condition here. That means definitely the function call has a return value that is either 1 or 0 in C programming language. In Python or Java, it is going to be true or false. Okay, that means definitely this function is going to be written either 1 or 0. If it is true, that means if it is written 1, that means if of 1, if of 1 means yes, the element is found, then it is going to be printed true. If it is going to be 0, if of 0, that means it is going to be false, and it is going to be print false here. Clear everyone? This is just a main function. That's it. That's it. I'm not writing any logic here. I'm not writing any logic here. Just simply I'm reading the input, and I'm going to printing the output, and this is the function here. This is the function, and this function I have to implement in the function definition. I think clear everyone, right? Clear everyone? For example, if I execute at this position, if I execute at this position compilation, it is going to be giving an error. What is that? Undefined reference to the linear search. That means we are going to define it. The return value of the function is going to be integer. Why? Because the function is going to be return 1 or 0. 1 or 0 is going to be represented with the integer, right? That's why I'm going to, the return type of the function is going to be int, and the function name is going to be linear underscore search of, and here I am going to pass two arguments, and the first one is array. Array means that is the first values address. That's why I am going to take here a pointer, and the next one is just simply a size. That's why I'm going to write int n, or we can write int size. We can take any variable. That is not a big problem. Yes, for example, if I compile it now, just observe here, there is no errors and there is no warnings here. Why? Because for this function call, there is a function definition. There is a function definition. That's why it is not showing any error or warning here. Clear, everyone, I think. Now I am going to implement the logic here. That is, I am going to take I, that's it, nothing else, and I am going to write a for loop. Why I am going to write a for loop? I am going to write a for loop. I am going to start from the starting index, and I am going to the last index. In between that, if the element is found, I am going to return 1. If the element is not found, I am going to return a 0 here. That's it, right? Now I am going to start from the starting index, and I have to move towards the last index, and every time I have to increment I plus plus. That's it, nothing else. For every time I am going to check with if error of I is equal to search element. I forget one thing here. I have to pass what element you have to search also, right? That is the missing here. I have to pass the search element also, and here I am going to write the search element here. Here, if the array element is equal to the search element, just simply I'm going to return 1 here. That's it, nothing else. If the element is not equal, for example, I'm going to check with 5 is equal to 66. No, then what will happen? It is going to be checked with first value with such element. We cannot decide that, we cannot tell that yes, the element is not found. We have to check to the last element, right? Up to the last element. Then again and again it is going to be checked. First of all, it is going to be checked with for example, the elements are only 5 elements, and I'm going to check 1 here. Is 1 is in the list? No. How I am going to tell? I'm not going to check with a single element. I cannot decide that yes, the element is not found. I have to check each and every element in the list, then only I can decide, right? That's why here I'm going to check with 5, then 6, then 7, then 8, then 9. Then the loop is terminated here. That means then we can tell that yes, the element is not found. If the element is found at this position, it is going to be terminated. If the element is not found, just simply if the loop is terminated, normally we can return yes, the element is not found. That's it. If I am going to execute it, just simply I am going to write this is the input, right? This is the input. I'm going to copy this, and I'm going to execute it. If this is the input and 66 is the input, yes, it is going to be tell that true. Yes, the element is found here. The element is found. Yes, true means the element is going to be found. If I'm going to execute it, if again the value this is going to be 6, is 6 is in the list? No, that's why it is going to be written as a false. Okay, in this way it is going to be executed. It is going to be executed. And the time complexity for this algorithm, the linear search is for example, I am going to search here 5, the best case. That means always that means the I is at first index position, the I is at first index position, the I'm going to check with search element with the first value. Yes, the element is found. That means in order of one time, the first iteration it is going to be found. For example, the element is not found, or the element is as the last element. If you observe here, it is going to be traverse all the elements in the list. That's why the time complexity of the linear search is going to be order of n means the size of the array. We have to traverse all the elements here. Okay, this is the program for linear search. Just try to execute it, and first of all you have to understand, and you have to try to write your own program, I think. Yes, is it clear everyone? I think if you have any doubts here, if you have any doubts, just comment it. Okay, if you like this video, just share to your friends, and give thumbs up here. Okay, and yes, in sometimes the program is going to be like this. At what position it is going to be found? For example, I'm going to find here a 66. Where the 66 is? The 66 is at fourth index. Okay, for example, the 6. Where is the 6 here? Where is the 6 here? The element is not found, right? At that position, we have to return -1, not 0. If we are returning 0, that means it is at 0th index. If it is not found here, just simply I have to return here -1. Okay, I'm going to convert this program into at what position it is going to be found. Just simply here I'm going to write, I'm going to modify all the code here. Just simply I'm going to write position is equal to, just simply I'm going to write the position is equal to, that's it. And simply I'm going to print what the position is, what is the position is, that's it, comma pos. Position is equal to, I'm going to declare that position also, comma pos. That means I'm going to return here, return I here, that's it. And instead of returning 1 my 0, I'm going to return -1. -1 indicates the element is not found. What is missing? Okay, one more bracket is there, that's it. I'm going to execute. Sorry, I have to copy the input. If I'm going to execute it, yes, the value is going to be 66. 66 is at fourth index position. Just observe everyone. If I'm going to execute it, if it is going to be 6, it is going to be written -1. The element is not found, that's why it is going to be written -1. I think, is it clear everyone? I think how I'm going to implement this one. Yes, these two programs what I am writing here, in the next video I'm going to discuss with recursion technique here. That's it for this video. Just comment it if you have any doubt. Just share to your friends if you like it. Thank you guys.